Quantum black hole firewalls. Do event horizons destroy information? In modern theoretical physics, this is one of the most violent questions hidden behind the smooth, silent geometry of a black hole exterior. For a century, we believed black holes were perfect graveyards of information where nothing escapes and nothing matters beyond the event horizon. But quantum theory does not allow information to vanish. Unitarity insists that whatever falls in must be recoverable in principle. This conflict became sharp when Stephen Hawking showed that black holes radiate slowly and evaporate, seemingly erasing everything that ever crossed the horizon. To repair that contradiction, physicists proposed black hole complementarity. It says there is no single observer that witnesses both smooth infall and information escape. An infalling observer sees a calm horizon. A faraway observer sees scrambling and re-emission of information in Hawking radiation. Both are allowed as long as no observer can access both at once. Then Almheiri-Marolf-Polchinski-Sully attacked this with a consistency check. If information must come out after the page time, then outgoing Hawking quanta must be entangled with interior partners to preserve a smooth vacuum at the horizon. But they must also be entangled with earlier emitted quanta to preserve unitarity. One quantum system cannot be maximally entangled with two independent systems. One entanglement must break. If the interior entanglement breaks, the horizon is no longer smooth. The infaller hits a firewall, a sheet of Planck-scale violent energy that roasts anything crossing. That destroys the equivalence principle and the general relativity picture of harmless horizon crossing. If, instead, we break the outer entanglement, we lose unitarity and information is destroyed. That breaks quantum theory. If we deny that the two Hilbert spaces are independent, we invoke exotic non-local relations such as ER-EPR that glue inside and outside in wormhole-like fashion. If we accept firewalls, we break general relativity at a macroscopic surface, not only at singularities. That means spacetime is not what GR says even where curvature is small. Thus, every exit from the paradox breaks something sacred. Either no drama at the horizon dies and firewalls are real, or locality dies through non-local information transfer, or unitarity dies and information is erased, or the semi-classical interior dies and never really exists after the page time. The firewall debate is about which pillar physics is willing to sacrifice. The paradox forced theorists to use holography, replica wormholes, and quantum extremal surfaces. These give a page curve that bends down again, consistent with unitarity. That means information is not truly lost but encoded in subtle correlations of Hawking radiation. Yet this does not automatically guarantee a smooth interior. It may instead mean the interior is emergent, reconstructed from outside data, and not an independent region. That kills the naive geometric picture even without literal firewalls. To stretch the question into the deeper stakes suitable for a 10-minute narrative, we must now look at what is really at risk. If firewalls exist, then the equivalence principle, the cornerstone of general relativity, is wrong at the most gentle entry point of a black hole. General relativity says nothing special happens at the horizon. A freely falling astronaut should drift across without noticing. A firewall says no. Nature detonates at the threshold. That is not a small error. That is a betrayal of the geometric faith that GR demanded. On the other hand, if we forbid firewalls, then something else must give. Perhaps information escapes through non-local processes that appear to violate relativity's ban on faster-than-light signaling. Perhaps the interior of the black hole is not a region of space-time at all, but a holographic mirage encoded externally. In that view, inside is not a place. It is a derived description built from entanglement patterns in the outside radiation. In such a world, the event horizon is not a border of space. It is a border of description, telling us when classical geometry stops being the right language. This debate is not academic. It touches the foundation of what counts as real. If information can be erased, then determinism in quantum mechanics dies. If information cannot be erased, then spacetime must bend its rules to protect information. Either way, something we thought permanent is disposable, and we have not even addressed the philosophical pressure. What does it mean for information to be real if bending the structure of spacetime is required to defend it? Is information more fundamental than geometry? Are bits more primary than space and time? The firewall paradox pushes us toward the idea that geometry is emergent from entanglement. If so, then destroying the required entanglement pattern at the horizon to protect unitarity may literally destroy the interior geometry. That means the firewall may not be an explosion of energy but an explosion of ontology, the interior ceasing to exist as a meaningful region once the entanglement structure that would have built it is reassigned to the radiation. Meanwhile, new tools such as the island formula in gravitational path integrals seem to show that to compute the fine-grained entropy of Hawking radiation correctly, one must include contributions from interior islands. This mathematical trick is not merely a technical fix. It signals that what we call inside and what we call outside are not independent regions. They are quantum entanglement-identified parts of one encoded whole. That, again, undermines the classical picture. You cannot draw the interior as a separate compartment once the theory that saves information literally identifies part of the interior state with part of the exterior radiation state. It means the intuitive cartoon of a traveler falling behind a curtain is a false mental model. No experiment will rescue us soon. Black holes that could test this are too far, too calm, too dark, and even if a probe crossed a firewall, it cannot transmit its death certificate. So theory is the only battlefield, and theory has cornered itself. Firewalls are not an exotic side effect. They are one of the only consistent answers left if we refuse to abandon unitarity and locality simultaneously. If firewalls are false, then we accept radical non-locality or emergent interior. If firewalls are true, then general relativity's proudest promise fails at the edge of a hole. In all options, the classical picture of a gentle event horizon is dead. The horizon is not a boundary of silence. It is the exact place where nature is forced to choose which law to betray to keep the rest of reality consistent. In this sense, the question, "Do event horizons destroy information?" is badly phrased. Horizons do not destroy information. The paradox destroys illusions. The illusion that geometry, locality, and unitarity can all coexist peacefully. Something must burn. Whether what burns is information, or locality, or the interior itself, the firewall paradox guarantees that the event horizon is not what it once was in the imagination of physics. It is the front line where the deeper rewriting of reality has already begun.